welcome to our last exam prep session. By the way, you do have enough time to take the exam if you walk out of here and just go register and start it. I believe, someone know when the last exam starts? Is it like 1-ish? That's probably for some of the longer ones. I was told you can take this exam after this session, which ends at noon. So the exams are at different lengths, and so the longer ones you would have to start earlier because they have to clear out of the rooms. So here's our ubiquitous what we're going to cover slide. We're going to do some technical content and some technical content. We'll talk about some exam tips. Hopefully I'll throw in some more technical content. We'll have some exam questions, prep questions. So we're going to get some complex, or I don't know, they might be considered complex topics. To me, most of them are fairly simple. But I have a whole section on async and await because that confuses people, and I like to explain that. And I have a really good slide on it that talks about it. Some sample questions. There will be no console.writeline hello world. In fact, for this session, I don't actually have any demos. For my ASP.NET 1.0, .NET Core 1.0 sessions, I actually did nothing but demo. I had 3 slides. So actually, let's do this first. I do have a demo I want to do. Hopefully this will work. Okay. Perfect. So if I move this to the other screen, come on. It's not letting me do this. I wanted to go, it's thinking. I wanted to go online and I was going to show you the exam website. There's a few things I wanted to talk about there, if it lets me. It's still sleeping. I will come back to it. But the exam what I wanted to show you, but it wouldn't let me, is the website, the Microsoft.Learning certification website, tells you everything that's going to be on this test. Not specifically, but it gives you all the major topics. In fact, I know we have a slide on it coming up, so I was going to show you. And it also has all kinds of helpful hints about how to prepare for the exams. A really good way is to go next door, and there is free measure up for almost every exam. Every exam we're offering here, pretty much. And you can go sit there and play with that. Also, if you go downstairs to the immersion zone, it's 50% off exams here, but even better, 40% off an exam that you take between now and the end of October, and 30% off a measure up that you just have to redeem the code by the end of October. And the codes are downstairs. I should have brought that slide with me. I don't have them up here, but I'm working the booth downstairs, and I'll be happy to get you you just text. You just do a text. For international people, it's going to be an email because the system doesn't work on non-US phone numbers. But we have a workaround, so we can get you the code, and then you can take the exam as you will anytime between now and the end of October. All right, this is the old developer roadmap. That's not good. I changed it, and it didn't get changed in the slide deck. The developer roadmap we have downstairs, it's essentially 2 exams, I believe, will make you an MCSA. Another exam takes you, oh, there it is. Thank you. Yes. We have cards, too. It is 2 exams for an MCSA and an elective for an MCSD. The MCSD, I'll give this back to you. Actually, they're outside. We have cards like this outside, lists the schedule, what you need to take. It's 2 exams, you become an MCSA. 1 more exam, an elective, you become an MCSD, and it's tied to a year, 2017. Does not expire. Okay, you'll always be an MCSD 2017. If you take an elective next year, they change your year to 18. And essentially, you stay current by taking one exam each year from the elective list. So it's a much, they introduced this last year. It's a much, much better way to do certifications, I think. It's much easier to stay current. It's much easier to get your MCSD. Let's talk about that for a minute before we get to slides. Because one thing that I've seen a lot of or heard a lot, even talking to employers, is they don't think there's a lot of value for developers in getting certified. And that they all look for experience. And it's true, experience is really, really important. However, there's a couple of reasons for certification. The first one is that if there's two people that are really close, certification can put you over the top. You can be the candidate they pick because you're certified, and the other one that's really close to you is not. The second one is that we all have to get through hiring directors, and I have a story about that. This was way back in 2005, and I was going for a .NET job, and in the description it said they wanted 5 years experience in .NET. Only problem was .NET was released in 2002. Nobody had 5 years experience in 2005 unless you were on the product team. Obviously, that was written by a hiring manager who did not know that. So certification gets you past a hiring manager who doesn't necessarily know anything about development, so you can't, your experience may not overwhelm them, but they're like, oh, they're certified. So that's the other reason I really like certification, is it gets you past the hiring managers that sometimes don't know what they're talking about. All right, so there's a number of skills measured on the exam, and they are weighted, and I was trying to show you on the website where that is. If you look up the exam on the website, you will see that there is a list of skilled measures and what percentage they are of the exam. So, and then they have a list of what things in that general bucket they're actually looking for. You won't get tests on every single thing. You won't get a question on every single thing that's listed. Also, even if you take the, you look at the exam guide or you take the class, it's not going to cover everything on the exam. And that's for any Microsoft exam. All the Microsoft exams are written so that you need some real-world experience in order, I don't want to say in order to pass it, but in order to get a really good score on it. So there's going to be some questions there that are not covered in the classes or in the book, and the reason for that is because they want you to have some real-world experience on top of everything else. If you need real-world experience, there are hands-on labs downstairs that I think are open till 2. And if you go to the MyIgnite website, those same hands-on labs are available to you for the next 6 months. So you can go do any of the hands-on labs here, even if you didn't get to them while you're here. You can go do them anytime you want, next 6 months. All right, the last time I looked, these were the approximate percentages. Check the website to get the most current version. This test, by the way, hasn't changed. There are other tests that change really, really often. The Azure tests are checked, if not updated, every month to 2 months, because Azure updates every 3 to 6 weeks. The product itself is on such a fast turnover that they have to update the exams that often. So it can be a challenge. They usually, sometimes, put the date on the exam when the exam was written or when it was last updated. They don't do that for all of them, and sometimes it's a little tricky to find. I believe they're changing that in the future, so it'll be easier to figure out when the exam was last updated. For C#, the product doesn't change as often, And to be honest, the basics are still the basics. An if statement is still an if statement, and it has been since .NET 1.0. Actually, since VB6, if you want to go really far back. So managing program flow, creating and using types, debugging, data access, they're all roughly a quarter of the exam. So let's go look at managing program flow. To manage program flow, we have a bunch of options. For example, threads. The advantage of a thread, it gives you complete control over your thread. The disadvantage of the thread object is that it gives you complete control over your thread. And that is a double-edged sword because sometimes it's really good, and sometimes if you don't do it right, it can be really bad. Microsoft has added some improved the threading window over time in Visual Studio. They did a big update on it in 2010, and then they updated it again recently. The thread pool is really cool. The thread pool makes it a little faster to spin up a thread. When you use the thread object, you actually create a thread. You have to spin it up, and that takes resources, CPU, memory. But the CLR already manages a pool of threads, and so often it's more efficient to just grab one of those and use it rather than create your own. It's already running, it's sitting there, nobody's using it. Why don't I use that thread? And so that's what the thread pool is based on. Neither of these methods make it easy to, well, let's go here. Thread affinity. How many of you know what thread affinity is? A few of you. All right. This is an important concept because it covers, it's actually part of everything on a computer. Thread affinity is simply states that an object created on one thread can only be accessed by that thread. So let's think UI. I create a button on my UI. When I create that button, the UI thread is the only one that can access it. If I have code running in the background on that screen, then the screen itself can become unresponsive. And I am sure everybody in this room has seen not responding. Is there anybody who's never seen the not responding? See? Everybody. So, not responding. Do you know why that shows up? It shows up because the UI thread is doing too much work. The UI thread is too busy doing something that we don't care about, or that the user sometimes doesn't care about. And so it's not able to respond to the end user. So we want to put stuff off on a separate thread. That's always a good thing. The guidelines for Windows 8 Store applications were that if it was more than 50 milliseconds, if whatever you were doing took more than 50 milliseconds, it should be done asynchronously. So how do you do things asynchronously? Thread pool. There's also a background worker. The background worker is the only one of these that allows for data to be sent from the background thread to the UI thread. These two methods require a lot more work than a background worker. The background worker is based on events. I don't have a slide on it. It is based on events. There's a do work event. That's what happens on the background thread. But there's there's an event handler object that has a result property that you can set in the do work event handler. And then you can actually read that in the run worker completed event handler. The run worker completed event handler is what runs when the background worker is done. And so it's possible to send messages to the background worker and get it out. It's very similar if you have used a background thread in JavaScript. It's very similar to that. But Microsoft has come up with a new way to handle background processing, and that is something called a task. A task, in many ways, whoa, what just happened? Oh, there it goes, okay. I looked and there was nothing there. I got scared. A task is a really simple object. It has 3 states that it can be in. The I'm working on it, the I'm done, or hey, there was an error. They can have a return type. Tasks can have a return type to them. Because sometimes we'll create a task where we want to keep track of this background process, but we also want to return data from it. Tasks are really great objects, and they help us with async and await, which we'll cover in a minute. Okay. All right, this is a little hard to see, but we're actually creating a thread here and doing some work. The point of this one is this. This is actually the do work down here. That's the event handler I was talking about. Now, when you do stuff on a background thread, you can't just cancel it. Let's say I open a file on my background thread. If I just kill that process, what happens? File stays open, have to restart the computer to access it again. So we need to make sure that when we shut down a background thread, that we're careful how we do that. Because you don't want to have a situation where you have a memory leak or where there's a file handle still held. We need to be able to get at that, right? We need to shut down. So background workers, all these threads don't just shut down by themselves. We have to shut them down. If we want to cancel them, we have to actually cancel it. What happens is you have to tell the thread, yes, I'd like you to cancel, and then the thread has to say, okay, and it cleans up whatever it needs to clean up. It closes files, closes connections to databases, and then it can shut down. So how do we tell that thread that's running in the background that we want it to cancel? And by the way, the thread has to listen for cancellation. You have to write that into the work that's being done on the background thread. That's your responsibility as a software developer, as the coder. You need to say, okay, if this happens, I need to shut down properly. Because only you know if you have files open. Only you know if only the background thread knows what it's doing at the moment. And so only it can decide when it's appropriate to shut down. So how do we do that? We use something called a cancellation token. A cancellation token allows us to shut down a background thread. We call so here, we're creating a cancellation token, and we're passing it to the start new factory method on the task. That will start the work going on the do work is simply the work that we want done. The token, we're passing it as well. That's so that we can tell it when we want to cancel. So I can, on the UI thread, say to the token, tell the other thread, cancel, so that it can cancel. And that's what happens down at the bottom. Which it's not going to let me show you. All right, now, in 2012, so that's cancellation tokens. Essentially, you have to tell it how to do it. Let's do async and await. Async and await is the simplest method of asynchronous development. There are only 2 keywords to async and await. They are async and await. You add async to any method in which you want to use await. Await instructs the CLR to stop processing the code in the method it's in until that process is finished. In fact, I don't like that code. Let's look at something. Here we go. Let's look at this one, because this explains it really well. So we have a message pump. The message pump is simply the CLR doing work. It's the CPU doing stuff. And at one point, and we have async and await. and you'll notice we have it on both methods. Notice the one we call returns a task. That will become important shortly. All right, so someone clicks the button. We hit the await. We call load settings async. We go to load settings async, which also is marked with async. And we hit the await in load settings async. So when we hit this await, we create load settings async will create a task, or a task will be created for us. It will be marked in the I'm not done state, and it'll get returned to button one click. Now, load settings async has not completed running. The task does not say it's done, and therefore processing stops in button one click, and focus goes back to the message pump, which is then available to handle other UI stuff, like clicking another button. Eventually, load settings async, the awaited statement, so download async will finish running. Focus will go back to load settings async, and the rest of the code in that method will complete running. There can be other awaits in load settings async. And if that's the case, we will await those statements. Focus will go back to the message pump. But eventually, all the code in load settings async will finish running. When that happens, the task that we return to button one click will change state from the I'm not done state to the hey, I'm done. And therefore, focus will go back to button one click, and we will execute the rest of the code in button one click. In this case, we'll call update view. We can have additional awaits in button one click as well. Those await statements can call other methods that return a task. It is important that anything other than a top-level event handler return a task. Stuff doesn't work if you don't do it that way. So let's take a look at a little bit of code. This is one of my favorite bits of code. So here we have a async void for button one click. And in button one click, we call this send data method. And then we do something kind of silly. We await a task delay. And in send data, you'll notice it's async, and we await this get response async. Get response async is a method that is truly asynchronous. We also have this global variable, m_getResponse. And notice we're filling it in send data, and then we want to retrieve it in button one click. Now, the reason, well, sometimes this code works and sometimes it doesn't. Sometimes there's data in m_getResponse, and sometimes there isn't. And the reason for that is fairly simple. We're awaiting a task delay. Well, the task delay time was probably thought up by a developer on their computer, and their computer is probably pretty fast. And it may be that the computer this is running on is not so fast. Essentially, well, let's go through this. So we click button one click, we hit send data, we go down to send data, we hit the await, focus goes back to button one click, we hit the await for the task delay, focus goes back to the message pump. Here's the problem we have. What's going to finish first? Is get response async, or is it the task delay? We don't know. We have no way to know. So if the developer was good and did the task delay long enough, usually it'll work. But like I said, sometimes this won't work, because quite simply, button one click has no way of knowing when the other method is finished running. So it has no way to know when mGetResponse has data in it. There's another problem here. And it becomes really apparent when I comment out the rest of the code in the button one click event handler. So let's say there's an exception when we call getResponse async like this. What happens? Well, let's see. Okay, so we click the button, we hit send data, we go down, we hit the await, focus goes back to button one click, and button one click finishes executing because there's no await statement there anymore. If there is an exception in getResponse async, it does not get handled in button one click. Button one click is finished executing. The try-catch block is not valid anymore. It's done. So it doesn't get caught there. Instead, the exception gets passed to the OS. Depending on which OS you're using will depend on what happens. On Windows Desktop, it'll crash the application. On Windows Phone, it generally just eats the exception and keeps running. Doesn't work right, but it keeps running. That's just what Windows Phone does with exceptions, unhandled exceptions. So that's what you get is an unhandled exception. This is a really easy bunch of code to fix. Here it is. Oh, man. Missed a slide. The easy way to fix it is this. If, instead of awaiting the task delay, I await send data, and I have send data return a task, I can get rid of the await task delay, and then all of this code works exactly as it's supposed to work. In other words, async void is only for top-level event handlers. It is a common mistake, especially when async void first came out in 2012. The product team ran into this a lot. You can parallel different things too. Let's talk about that for a minute. There's a different, how many, I'll just go. There's parallel and there is asynchronous. Those are two different things, and they are generally are used for two different purposes. Asynchrony is usually used for I/O. Parallel is better for CPU-intensive tasks. You have to be careful with that, though, because sometimes stuff can look like it's CPU-intensive, but it's not. So look at the code. If it waits for something, if it waits for a response from a web service or waits for a database, any place where you see it could be stalled. That's a better choice for asynchronous rather than parallel. .NET has both parallel and asynchrony built into it. We have async and await, and we have things like parallel for. And parallel for is so easy to use. Parallel.for each. Suddenly, that thing runs in parallel. I didn't have to change how I wrote my code. I just added a keyword, and voila, it suddenly runs in parallel. I know it's a little hard to see. They didn't install a plugin, or I didn't install the plugin here. These slides should be available through the website. I sent them up there a long time ago. If you go into, long enough ago that it had the wrong schedule in it, the wrong path. That was the first set of slides. And then they said, no, fix that. So I sent them a new set, and they didn't put it on the machine. Not my fault. All right, so parallel for. So that's a really nice way of getting parallel programming. You can do parallel for each. There's a whole bunch of parallels. Link, you just say, yeah, I want to run it in parallel. For statement, yeah, I just want to run that in parallel. But be careful that it's not doing something that's I/O intensive, because if it is, you're better off using async and await rather than parallel.
Or if you expect your results to come back in a certain order.
Yeah, there are ways you can actually do parallel so that they do show up in the order you want. All right, let's try a question. So we have some code here, as you can see. And the method takes several seconds to complete. So we want to make sure our code executes as fast as possible. What should we do? So who thinks the answer is A? Anybody? No? How about B? Anybody? C? A couple of you? D? And the rest of you are not sure. The answer is C. Here's why. We don't want to run, that's the correct syntax for getting it to run in parallel. So we want line 3 to say items.asParallelWhere. Otherwise, they come out in the wrong order. Here's another one. Let's try another one. We have a method that accesses a database. There's some code. And we want to ensure the original exception is thrown back to the caller. What should we do? A. Who thinks it's A? Most of you. How about B? Anybody? Okay, 1B. How about C? That's good. How about D? 1D. All right, returning EX won't throw the original exception back to the caller. It'll pass it back to the caller, but not as an exception. It won't, it's not this will just send it. The actual correct answer is A. Throw EX will throw it as an exception. Throw new exception with EX in it will create a new exception and have EX, whatever that is, as the inner exception. So throw is the correct answer. All right, let's talk about types. It is cool. All right, so let me see what constructors and inheritance. This is a good one. So code's a little hard to read, I know. But here's the point. So there's 3 kinds of constructors. Hopefully you're aware of this. There are default constructors that take no arguments, non-default constructors that take arguments. And if you don't put a constructor in, the compiler says, I'll bet you want to create this class. So the compiler creates a default constructor for you, but only if you don't include one yourself. If you make a non-default constructor, the compiler will not add a default one for you, only if you leave one off. If you put no constructor in the class, the compiler will add a default one for you. So start with that. Now, let's move on to inheritance. If I inherit from a class, the first thing that happens is the constructor in the child or derived class gets called. And the first thing that constructor does is call the constructor for the parent class or the base class. And it works its way up the inheritance chain. Everybody's aware, I hope, that object is the parent of everything in the .NET framework. Whether you say it or not, it eventually winds up there. All right, so if we create a non-default constructor in the base class, we must create a constructor in the derived class. The reason being, what does the derived class do when in its constructor first thing? It calls the constructor for the base class. Otherwise, how would it get all the properties and methods from the base class? It has to create one to get them. So how can the derived class automatically call a base class constructor that takes arguments? How would the derived class know what to pass? What argument do I pass? There is no way for the derived class to know that. The compiler can't add a constructor for it. You get a little squiggly that says, hey, you didn't do this right. Because there's no way for the derived class to call the base class's non-default constructor. unless you write one. In the derived class, your constructors could be a default constructor that still calls the non-default constructor. You just add whatever argument you want. You can use a non-default constructor in the base class that passes the argument through, or you can create a non-default constructor in the derived class. See, too much coffee. Call a non-default constructor in the derived class that calls the non-default constructor in the base class. And the argument that you pass into the non-default constructor in the derived class just passes the argument through. You can kind of see that here. Here we have custom constructor. This is a class. Here's our non-default constructor. It takes a string. Here's our derived class. And in the derived class, we have another non-default constructor that takes an argument, and we're just passing name to the base class's constructor. And that's an example of exactly what I was talking about. So there you can see it. That's an important concept. Sometimes people get tripped up on. Generic methods in classes. You guys know about generic methods in classes? Everybody? Anybody not familiar with it? A generic method or a generic class is simply a class or method that has an argument that is a data type. And when the CLR and they're really good for collections. Collections in the framework are are non-generic, meaning that you can put pretty much anything in them. I can put strings and integers and whatever else I want. The problem with that is when I retrieve the data, I better know what the data type is, or I'm going to get an exception. And that's one of the advantages of arrays. Arrays are type safe. Arrays, we know what data type an array is holding. We declared it. The CLR won't let us put something in it that's not the right data type. So we have generic collections, which are really not generic because they're type specific. And when we declare a generic collection, we tell the CLR what data type we want to use. That can be really handy because, for example, the framework has the list of T. A list of T is the type, can be a list of string or a list of object or a list of integer or a list of whatever I want. The CLR will actually create a separate class for each one, each data type. So it'll create a list class that holds strings and a list class that holds integers. The CLR will do all that for you. Here we have a generic class, class 1. And we are making it a generic class. We have a type parameter being passed in, T1. And this is pretty new, pretty cool. We can restrict, when we create generic classes, what data type they take. In this case, I'm saying that T1 must be a class, so it can't be a structure, and it must have a constructor, a default constructor in this case. Or here, the second one, T2, is also a type. T2, I'm saying it must implement the iClonable interface. If it doesn't implement the iClonable interface, I can't pass in whatever for T2. So here's another example. We have a class, class 1, and we have a method where we have a using statement in that method where we're creating a new class 1. We want to make sure class 1 it works correctly in the using statement. What interface should we implement? Which one, B? Yeah. This one's wrong. It says A, iClonable. All right, let's try another one. I like doing ones that don't work right. It's more fun when there's stuff I can make fun of. All right, here we go. We have some code. We have a class called program. It has a static void main. It has a, we're creating a new class 1 in it. Our new class 1 has a list of string that we're calling collection 1. And we need to add string 1 to collection 1. Which lines of code should we use? Who says A? B? Anybody? Nope. C? D? Yes, C and D. All right, debugging applications and implementing security. What am I doing? Oh, got about half hour left. Okay. Let's talk about encryption. I don't know how basic I need to get. How many of you are familiar with encryption? About half. Okay. How many of you are familiar with the difference between asymmetric and symmetric and hashing? Anybody? About 3 of you. Cool. Let's talk about that. Let's do some, I love doing this kind of stuff. This is my fun stuff. Let's talk about it. All right. 3 kinds of encryption in general terms. There's hashing, asymmetric, and symmetric. So let's talk about the differences. In symmetric encryption, I encrypt some data and I send it to somebody else, and they unencrypt it using the same algorithm, or the other half of the algorithm, and the same key. The key that we use has to be the same on both sides. Now, that's fine if they're down the hall, or they're in the same building, or we're meeting up at a conference like this and I'm handing them a key, or they hand me a key. But over the internet, that doesn't work so well. Trying to get, I don't want to send the key plain text in an email. That's not going to be very secure, is it? So we had to come up with another way. Asymmetric encryption. In asymmetric encryption, we have 2 keys, and they're mathematically related. One's called a public key that I can give out to anybody, and one's called a private key that I keep to myself. In asymmetric encryption, we use 2 keys that are mathematically related and an algorithm, and someone can take my public key and encrypt data, and the only way to unencrypt it is with a private key. You can't unencrypt it with a public key. Has to be done with a private key. Likewise, if I encrypt data with a private key, the only way to unencrypt it is with my public key. You're going to go, well, that's not very secure. No, it isn't. But it's really good for ensuring that data wasn't tampered with. Because if someone tampers with the data and you use my public key to unencrypt it, it won't unencrypt correctly. So doing it the reverse is really good for determining if data was tampered with. Hashing. Hashing is the 3rd kind of encryption. When you hash something, it cannot be unencrypted. We do passwords that way. Passwords get hashed, and then the hash gets stored in a database. These systems are used all over the place. For example, SSL. How does SSL work? Under the covers. Since a lot of you didn't know the difference between asymmetric and symmetric encryption, I'm going to assume you don't know, so I'm going to tell you now. Asymmetric, in SSL, we start off with what's called an asymmetric handshake. Essentially, you would call a server, would send a message to a server saying, I would like to do an SSL session with you. The server will respond with their public key. You will take their public key and use it to encrypt a symmetric key. So the client will create a symmetric encryption key, and it will encrypt that encryption key using my public key. Then you will send the key to me. I will unencrypt it using my private key, and now we can use symmetric encryption to send messages back and forth. And you're going to go, why should I do all that trouble? Why do they go to that trouble? And the answer is something I didn't tell you earlier, which is symmetric encryption is lots faster than asymmetric encryption. And that's why we don't use asymmetric encryption in SSL, because it's slow. Symmetric encryption is faster, so we want to use that. And that's how SSL works. And in fact, we can exchange new keys. You can exchange new keys all the time. When you get a certificate from VeriSign, often it will say, oh yeah, there's a key in it. There's actually two in it. There's a private key and a public key in your certificate from your certificate authority like VeriSign. And the public key gets sent out and the private key never does. You know what Microsoft's most valuable thing is? Its key set. More valuable than the source code for Office, more valuable than the source code for Windows. The reason for that is because if I had Microsoft's private key, do you know what I could do? I could send everybody all around the world hacker programs, and their computers would say, hey, I verified this came from Microsoft, and you would run it. And then I would destroy all the computers all over the world. Ha ha, evil genius. Okay, not so evil. But that's why that's so valuable. All right, so we've talked about what this is. So symmetric encryption uses a single key. It's reversible, meaning I can encrypt and unencrypt it. So hello world becomes blah, 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 whatever that is. There are three main algorithms. Never, ever, ever attempt to write an encryption algorithm because you will not be able to do it. Well, you might make one that works, that's able to encrypt and unencrypt using a key. The problem is that hackers will be able to do it too. Another important thing to remember is key size. The bigger the key, the more secure it is. As we get faster and faster computers, we need bigger and bigger key sizes. A few years ago, probably 5 years ago, they discovered like I think it was a 32 or 64-bit key on one of the algorithms was able to be broken by a computer in less than a day. And so they needed to, I think that algorithm is going out of favor, but they used longer keys with it. So there's a DES, RC2, triple DES, all those are built in, so you don't have to know what the algorithm is, which is good because I could never figure it out. But this takes care of all that for you. You just use it and you create a key. It's pretty, I don't want to say it's easy because it's not simple, but it's a lot simpler than if I had to actually try and encrypt something. Asymmetric encryption, two keys, reversible encryption. So we get hello world, it becomes that, it goes back to hello world. I explained how that works. There are different algorithms for that. DSA and RSA are probably the most popular. Hashing, irreversible encryption. Hello world becomes this, we can never get it back. Any website that can send you the text you wrote for your password, you should never go to again. That means they're storing the password somehow so you can unencrypt it. Or they would not know what your password is, which means they're unsecure. Here are some hashing algorithms that are part of the framework. Serialization and deserialization. This is a very common process. It is also one that is good for parallel programming because it's CPU intensive. So what we did is we created a class called employee. We have two properties in it. We have our main method. We're going to create an array of employees. We are going to create a memory stream. We're going to use something called a data contract JSON serializer, which is the line of code that I wanted to talk about. So the data contract JSON serializer actually implements an interface, which means there's actually two main serializers. They can both be interchanged because they implement the same interface. So it's really simple if you don't want to use JSON and you want to use something else. Writing to the event log. I want to talk about this too because there's some catches here. So here we're writing to the event log, but before you can write to the event log, you have to register your application with the event log. In ASP.NET, all right, let's take a step back because I got to explain a couple other things. So all code runs under a security context. I assume most of you knew that. Or a user account. That's the simple way to describe it. But it's essentially a security context. It has some permissions. Okay, it's allowed to do certain things. Even ASP.NET, even web applications, that code in the web application runs under a security context. It's allowed to do certain things. By default, the security context that runs ASP.NET web applications does not have permission to register something to the Windows event log. It can't register the application. It can write to it, but it can't register it. Writing to it, almost any application can do. Let's go off test for a minute and let's talk about some best practices, shall we? Does that sound fun? So, best practice. I don't like writing to the Windows event log. It's easy, but I don't like doing it. Unless it's like a web application, and then it's okay, because I don't have that many servers. When I have 60 machines running a Windows application, it's a pain in the neck to go to all 60 machines and look at their Windows event logs. So I like to put them in a central location. But you have to be careful, because my favorite really bad thing that I did, no, that's not the problem I had. My problem was I wrote code. It wrote it to the database. Okay, put it in a catch block. Every catch block in the application went to this class, which wrote my exceptions, not all of them, just the important, just the high-level ones. It wrote them to the database. Here's the problem. The exception that got thrown can't connect to the database. Then it went to the catch block. It tried to write to the database. Still couldn't connect to the database. Threw another exception. Got into an endless loop. We finally had to like shut down the computer to get it to stop. So don't just send stuff to the database, because that may be the problem. A friend of mine has a really good system. I think it's up at GitHub somewhere. The guy's name is David McCarter, and he goes by .NET Dave. And his system is really cool. I believe it's open source. Anybody can get it. He has a system where he has a web service. The web service receives the exceptions. The client-side code will check to see if there's an internet connection. And if there is, it will send the exception to the web service. If it's not, it will save the exception until there is an internet connection, and then it will send it to the web service. Now, he does consulting, so he has lots of different applications and lots of different companies, and this is a great way for him to keep track. You always want to track your exceptions. I don't track information messages. That just winds up being too much. Oh, and never email exceptions. Emailing exceptions will just make you crazy. You will get way too many emails, and then you'll stop paying attention. So don't do that either. Where was I? It'll come to me. Anyways, you can write to the event log. Like I said, that's not my favorite place to put exceptions. But for web applications, it works okay. The catch is to make sure that the application has been registered with the Windows event log, which you can't do in a web application. Here's how you can set up tracing in app.configure. You don't really have to do it as often in web.config. In app.config, you can, tracing is based on a provider model. Lots of things in .NET are based on a provider model. Data access is part of a provider model. So how does this model work? Here, we have a source, and then we have listeners. And we can have as many listeners as we want. So the source can send data to 5 different listeners if that's what I want. And the idea is we're trying to separate sending the message to where it goes. Okay? I can send a message and it can go to 1 or it can go to 100 places. It doesn't matter. I add more listeners or change the listener, and then my exception information will go somewhere else. And that's really good. And it's nice to put them in a config file. Microsoft is moving away, this, as an aside, not part of the exam, Microsoft is moving away from the XML config files towards a JSON model. And there's a big, huge reason for that. And the reason for that is lots of code gets checked into Git, right, GitHub, and these config files tend to wind up there. And do you really want everybody at GitHub knowing your connection strings? Probably not. So they're moving away from that model. In .NET Core 2, they've actually made it really nice where you can have a separate configuration thing. You don't check it in, and the configuration will actually tie into things like the Key Vault in Azure, which is, by the way, a much better place to put things like connection strings because you don't want people getting them. Last, we have a switch down at the bottom. That sometimes comes up on tests. The switch is how much information I want to get. You can get like info, warning, errors. There's one other, someone help. Info. There's 4 levels. So don't generally go for the really low ones unless you want, huh? No. Warning, error, information, verbose. That's it. Thank you. Gosh, so much stuff in here. Sometimes it just gets all jumbled. So yeah, you don't want like verbose or information because that just winds up providing too much information and then it's too hard to find what you want. I am of the opinion that if it doesn't stop my program from working, I don't care about it. So I only care about errors. But that's just me. I'm also lazy. So after you configure it, you can use it. Tracing. It's pretty easy. You can also, by the way, anything you do in app config, you can do in code pretty much. It's not as good a way to do it because doing this in code means you can't change it later without recompiling the code. One of the reasons that we have configuration files and configuration settings is so that we don't have to recompile code in order to change how our program works. That's really important. I've worked in companies where when they QA the code, you're not allowed to change it without it being QA'd again. And if I need to change a connection string going from development to QA to production, I don't want the QA department to actually be testing this thing on production database. That would be awful. So configuration is really important. Microsoft is well aware of that. Configuration isn't going away. They're just changing it in the new versions. You can trace programmatically. Here we are adding a new trace listener, giving it a name. There are things called compiler directives. Compiler directives are really interesting, and they're not used a lot. Compiler directives are ways for us to tell the compiler that we want it to do something. These were really important before the compiler became .NET. How many of you are familiar with Project Rosalind? A few of you. How many? Okay, let's talk about that for 2 minutes. Another aside. I'm trying to give you like enough other than just the stuff on the test. I'm trying to give you a little more value here. So here's the deal. Starting in somewhere around 2007, Microsoft decided that the compilers should be written in .NET. So the compiler for C# will be written in C#, and VB will be written in VB. Previously, they were all in C++ or C. Microsoft started working on it in 2007, and it took them till 2012 to finish. It took them a dang long time, and mostly because it was a moving, they were trying to get to something that was changing as they wrote the code. They would change the language, and then they'd have to change the compiler to match the language changes that they just made. So they finally caught up in 2012. And the rewriting of the compiler is called Project Rosalind. That allows for many things to happen. You can actually now write .NET code that will interact with the compilation process. They had some demos of things you can do with it. For example, you can write a class or a method that will go through all your source code and look for dirty words. So you can implement all kinds of code rules about how you write code, and can have them enforced by the compiler. So like fxcop, I don't know, does anybody remember fxcop? A few of you? fxcop was a tool that would enforce coding standards. So like naming conventions, things like that. Well, you can write all that yourself now and just add it to the compiler. It is open source, so you can obviously go check it out if you want a compiler. If you want to create, I don't know, piglatin.net, you certainly can do that. All you need is a compiler to change piglatin into valid IL code. Now it's called C. How many of you remember missile code? Intermediate language, it's now CIL, because .NET is a standard. They actually sent it to a standards body and got it standardized. And there's a board. There's a .NET board that helps decide how .NET works. All new development in .NET is open source. Go to GitHub if you want to see any of the source code, almost any of the source code. Data access. So databases are pretty simple, but streams can be a little complex. Here's some sample code. We're getting a file stream. File streams are used to read files. Let's talk about streams for a minute and why they are the way they are. Once again, provider model. There's file streams, memory streams, all kinds of different streams. Those are just, how many of you have seen that orange juice commercial where they stick the straw in the orange? That's what a stream is. It's the straw in the orange. It allows you to get access memory or files or whatever, but it doesn't do anything other than let you access them. So once we create a file stream, then we actually have to do something. We have to read the data. Depending on what kind of data we're reading will depend on what kind of reader we create and how we do it. We can also write to streams. Here's some more complex code, but we don't get to see the good part. Link. How many of you are familiar with language integrated query? Most of you. Good. How many of you know that by adding a simple keyword to link, you can make it run in parallel, and it gives you the results in order? Yes, just by adding the parallel keyword to your link query, it'll run in parallel. It's called p-link, parallel link. You can do joins in link. You can do grouping in link. Here's a good question. You're creating an app that processes orders, and you want to ensure all the orders are processed in the correct order, in the order they came in. What type? Who thinks a hash table? Who thinks a dictionary? Stack? Queue? Yeah, that was pretty easy, huh? Here's another question. Here's some code. This is an interesting one. I kind of like this one. So we create a list of integer, and then we are going to use link on it, and then we're going to go through a for each, and we're going to do another list. We're going to add another item to the list, and then we're going to do another for each. And we want both loops to display the same data. What do we do? Who thinks it's A? B? C? D? Nobody sure? The answer is actually A. Let's talk about it. So by adding toList to my link, okay, how many of you, let's start here. I think I only have about 8 minutes left, but this is a good thing to cover towards the end. Link. Link has deferred execution. How many of you know what deferred execution is? A few of you. Let's talk about it. So if I just do a link query, which is what this is, and we hit this for each statement, this is where link gets the data. It doesn't get the data until I use it. When I add an item to it, when I hit this for each, it's going to use the new data. It does not run the query up here on line 2 where you think it would run the query. This is called deferred execution. Deferred execution occurs anytime a link query does not, well, there's three ways to not have deferred execution. So let's talk about that because that's going to be easier. There's 3 ways to get it to execute immediately. ToArray, ToList, or if the link query returns a single value. So if you do like single or default, I think. First or default. If the link query returns a single item, it executes immediately. Or you can add ToList or ToArray, and it will execute immediately. Other than that, it uses deferred execution. Or you enumerate through it. Yeah, I'm almost out of time, guys. Here's some additional resources. I would say the best way, I have a couple minutes. Here we go. The best way to prepare for exams as far as I'm concerned. Go next door and use the measure up practice exams and see how you do. If you get about 80% on any of those, go ahead and take the test. You're ready. Okay? If you don't pass, I still like the measure up, and then I go back through it and I look at the answers and why it's the right answer, because the measure ups will tell you that. Be careful. Don't use brain dumps. Brain dumps, if Microsoft discovers that you've used a brain dump, it can take away your certification. It is against the rules. A brain dump is a website that tries to give you the actual questions and answers. So it's hard to do because you're not allowed to take the questions out of the room. And they don't exactly tell you which ones you pass and which ones you don't. 700 is a passing test on any Microsoft exam. The exams range from 30, 40 questions up, depending on the exam. Thank you. 5 minutes left. Don't be afraid to answer a question you don't know. You don't get points off for getting a wrong answer. It's not Jeopardy. I know I started with Jeopardy, but it's not Jeopardy. So, if you can eliminate a couple of answers, go ahead and do it. And then you got a 50-50 shot, and considering you're not going to lose anything if you guess wrong, guess. Another helpful tip, go with your gut. Generally, I found that every time I go back and change answers, that those are probably the ones I got wrong. I don't know for sure because I can't tell. But I do know in the practice exams, when I go back and try and change an answer, those are the ones I get wrong. So go with your gut. The tests for developers that Microsoft has, they seem very picky. They seem, well, let me explain. So Microsoft has to, for each question, Microsoft has to have a single correct answer. If they don't, they're going to get feedback. Oh, are they going to get emails? They're going to get lots of them. That said, they don't want to make it too easy. So while they don't intentionally try and trick you, they do have to include answers that might be plausible, right? That could work. They got rid of they're getting rid of the ones where they don't tell you how many answers you need. It's like, select all the appropriate ones. They're moving away from that. All the new tests don't have that anymore. I don't think they've revised this one yet. They have not gotten to the point where, and this is one, I would love it if they did this. I would love to be able to say, get some data out of a database and display it here. And then I'd love just to be able to write the code to do that, because there's many ways to write code, and we all use different ways to write it. But Microsoft can't do that yet. AI is not that good. Okay? It's getting there, but it's not there yet. So we can't have that kind of test, as much as I would like it. So yes, Microsoft does seem to be picky when they're asking the answers to the questions. But there is only one correct answer, and they're very careful about how they create the tests. Definitely go to the website, which I tried to show you earlier, and look at what the topics are. Those topics are what they give the writers. So when people write the exams, the question writers, exam question writers, whatever, those people, they get that list, and they write it based on that. The practice exams, like Measure Up, are also created from that same list, different developers, because they don't want to chance having someone who wrote an actual exam question write a test question that's the same. So different developers, they use the same list to work on what questions they write. The Measure Up is supposed to be harder. The idea is that the test, the Measure Up should be harder than the actual exam. Measure Up likes that idea. So does Microsoft, actually. Because then if you're passing your prep, you're ready for the exam. Let's see, I think that's everything.